Hello everyone, welcome to Algorithm Galaxy, and today we're going to see about two-sum problem. It is one of the common questions that you will come across in any interviews. And what is this two-sum is all about? So in this two-sum, we will be given an array like this. And the target, we need to figure out which two numbers of the given array adds up together to reach target, which means here in this array 2 and 10 sums up to reach 12. At the same time 7 and 5 sums up to reach the 12. We need to give the first instance of the sum. Basically it is enough only to give the first instance, and once we see the solution we will check the bigger complexities of the algorithm. This can be attained with two possible solutions. One is hash map solution, another is two-pointer solution. So what is the hash map solution is all about? In hash map we will be having an empty object. In this empty object we will be storing our results each and every time we loop. What result we will be storing? So at first we'll see how we can achieve this. Here you can see in this array of A element and array of B sums up together from the target. This can be also written as target minus array of B gives array of A number. This is the solution which we are going to take in this. This is the approach basically. And we will be checking at first whether the resultant value from this is there in the array or not. If it is in the array, we can simply return this and the resulted this value. If it is not in the array, then we will be storing this array of B value which we used to calculate now, which we were looping into this hash map, which is array of B is true, saying we've already came across this number, and in future while in other numbers while you're looping, if you get array B as your result, we will be checking here whether we have this array of B number is there or not. If it is there, then we can do it. So this is the purpose of hash map, and we'll go and implement this. This two-pointer solution will come back. So we will write a function of two-sum. This takes an array and a target. So at first we have to create a hash map. So the hash is equal to empty object, and we will be looping this array now. For I am taking a number of array. So now if I log the number, I will be getting each and every number which I'll be getting. So you can see that to sum of this array I am giving, and if we run this we will get the numbers. This is looping all over the number. Now we need to check the difference between this and this, which means difference equals target minus number, and we need to check whether this difference is there in the hash or not, which means earlier we came across. So you need to check if hash of difference is there or not. If it is there, then we can simply return the number which we've looped and the difference number. If we didn't find any different, like if our difference is not there in the hash, then we need to store the number which we loop now. So like hash of number equals true, which says, hey, in future if you come across a difference which results in this number value, it is there already in the array. I saw it. So this is the purpose of the hash. If we didn't find any matches, then we can simply return empty array. As we are returning it here, we need to console log the result. And the target value which we are looking at is 12. And we can run the code, and we are seeing it actually here. This is one solution. If you see the time complexities of this, so its time complexity is order of n. We can see here we have one operation, and we have for loop of n operations, and here we are returning 1, which sums up to form 2 plus n operations. As being a constant, we can remove it, and it results in order of n. And can remove this, and we can remove this. Space complexity. Here we have hash. This will add up each and every time when we see no difference got matched with the existing values. So, which means in worst case, we will be adding each and every element of the array to the hash map. So it is like the same order of n. Space is order of n. Oh, I mistakenly gave it as 0. It's big O of n. What is second solution? It's all about. Second solution is 2-pointer solution. What is that 2-pointer solution? In this 2-pointer solution, we will be having a left and right pointers. This left will point the first element of the array, and the right in turn will point the last element of the array. Given that array is a sorted one, and we need to sort the given array basically, and we will be adding these two elements together, and we will compare the resulted value of this addition with the given target number. If the target number is greater than our result, which means pairing with the target number. If the addition result whatever we got from our operation is lesser than the target number, then we need to increase the number, increase the value of the addition, basically. And that can be achieved with increasing the left pointer to one position to right. As it is a sorted one, for sure if you move the left pointer, then next element what you're gonna land in left pointer will be the highest one, like it will be greater than the one what we did before. Likewise, we will be like if our value is greater than the one which we've got as a target, then we need to reduce the value of a right pointer to one number less. So let's dive into solution. the same function to sum, and here we are getting array and target. In this, first we need to sort the array whatever we got. So sort of a comma b h a as b. This will sort the array, and we can achieve this by creating a left as 0 and right pointers. This right tends to array dot length -1, which will point the last limit of the array. This will be in a while loop, and we need to check the sum now. Const sum equals array of left plus array of right. This is the sum. We need to compare this sum with the target number whatever we got. We can check if the target is equals to the sum, then it is the result. So if sum equals target, then we can return array of left and array of right basically. If not, then we need to write else if the sum is lesser than the target, which means we need to give if lesser than, which means we need to increase our sum, so it is left plus plus, and other only option is if the sum is greater than the target number, then we need to increase the right position by 1. When we will be stopping the loop, for example, let's consider this as a 25. We can see that left pointer will be here and right pointer will be here. We will keep on adding, like at first it will be 11. We need to, I just move here this one. So each and every time I don't want to move the right pointer. Yeah. So at first it is 11. So we will be moving this and 13. And here, as it is lesser than 25, we'll be moving to next, and 15. It is still lesser than. And we will keep on moving until we get 19. And now we are reaching the same element. So we need to loop, or we need to loop the array until our left position is lesser than the right position. So this will be the condition for the while loop. We are coming here, and inside while we can simply give left less than right. And if we didn't find anything, then we can simply return empty array. That's it. So if we run our code now, we need to get the same result. 2,10. We got it. And if we check the big O complexities of this algorithm, it will be time of order of n. We can see that here we have a sorting operation, and it is of order n, and it is one operation, and it is one operation, and here we have while loop, and it corresponds to an operation, and here we have one operation. So it is 1 plus 1 plus 1 plus 2n. So it is like 3 plus 2n. We can remove this constants, and here also is a constant, so n is the one which will be accounted for a worst case. So order of n. Regarding space complexity, we are actually depend on only two variables, which is a primitive, and it won't increase or decrease its space depending on the array. Always it's gonna have this integer values, so it is constant time in space. So space is always order of 1, which is a constant time. Yep, and that's all about this. Thank you.